All right, guys, welcome to Monday. Go ahead and get out your homework. So we started our last chapter of the year. The homework was on permutations, basically, and the permutations formula. Didn't get any emails, so I assume that you guys were okay on this. Let's go over the answers. So let's see. It was 2 through 12 evens on the written, and then 2 through 8 on the problems. So on this starting with the written. Number 2, it was 6 factorial, and that's 720. Number 4, 8 factorial, 40,320, 40320. Notice, that's only two numbers different, 6 factorial to 8 factorial. Yet one is in the hundreds and one is in the tens of thousands. Factorials grow very quickly. Number 6, now we go into our permutation formulas. 5,040, number 8, 506, number 10, 1,680, and number 12, 506. All right, on to the problems. Number 2 is 6. This is basically using the counting principle. Number 4 is 12. Number 6 is 18. And the last one, number 8, is 6. There you go. Count up how many you got wrong. Go ahead and answer question 1 on the Google Forms. Okay, here's the calendar. We got basically these 3 weeks and then the finals weeks. Notice one quick change was announced to you in email. We're going to go one more extra week into the school year here. So here's how it's going to work. So we will continue on with Chapter 11 for 2 weeks. Notice on that next Monday will be a rest day. District 49 has told us we need to take a day off. That's the whole district. So May 11th will be a day off. And then we'll pick up on that Wednesday, Friday. And then that third week on the calendar you see right here, we'll do a semester final review on Monday and Wednesday. And then you will begin your finals week on Friday, right? And the reason why we're starting on Friday and not Monday is because that Monday is a holiday. So you'll take your English final on that Friday, 22nd. Then we'll have a 3-day weekend, and then we'll pick up on Tuesday. So I'll just go ahead and tell you your final schedule. Let's see. I know that the Friday, that final Friday is a history final. Let's see. Thursday is the math final. Wednesday is the Latin final, and Tuesday is what am I leaving off here? Tuesday is the science final. So it goes in order from Friday all the way back to the other Friday. It would go English, science, Latin, math, and then history. Those will be your finals. So you'll do one final a day. The only downfall to this is that we will review a week before you take your math final. So what typically what students will do, you pay attention during your semester finals. All the teachers will be reviewing for your finals. And then you got to keep that information handy, but you need to concentrate. For instance, after you do Wednesday's class, start cramming for your English final, and then each day after you finish that final, then start working on your next day's final. So it's a pretty good schedule. Only one final a day. You should be able to handle it, no problem. Plenty of time to study. All right, go ahead and copy down your homework. Once again, this one has got 2 parts here. There's no written exercises on this page. There's class exercises, 2 through 10 evens, and problems. So kind of like the same thing we had the previous one. Okay, so I'm just going to warn you. We talked about this already on last class on Friday. We did talk about what combinations were. Today we're going to get the formula for combinations. It is visibly a very busy formula. It's got a lot of stuff going on. If you did okay for the permutations formula, you'll do fine on this one. All right, so remember from last class, we talked about picking things. So if I give you 3 objects to choose from and I ask you to only pick 2, there's 2 ways you can do this. One where order doesn't matter, meaning I don't care which order you pick the items, right? For instance, you could pick square circle or square triangle or circle triangle. Notice that square circle and circle square would be the same 2 items, right? If I just say pick 2 items and you pick the square and the circle. It doesn't matter whether you say square circle or circle square. They're the same two items. When order doesn't matter, we call that combination, right? But when order matters, for instance, when the order that you choose them, right, could change. Circle square is not the same as square circle if the order, like which item do you pick first? When order matters, you get more things to choose from. So we call the one where order doesn't matter, we call that a combination. We call the one where order does matter a permutations. And I know for students first learning this concept, it's kind of challenging. So I'll give you a real world example. And I did use this on Friday as well too. So your mom says you can bring some friends to the movies, right? And she says you can bring 2 friends, right? It doesn't matter which 2 friends you choose. If you choose Fred and Nancy, that's the same as Nancy and Fred. It's the same 2 friends. So when you pick those 2 friends, you are choosing out of all your friends a combination, right? This is when the order that you choose them does not matter. However, when you get to the movies and you have to sit down, right, the order does, because there's only 1 seat for each person. So the order matters. This is called a permutation. Okay? And it turns out there's always more permutations than combinations. So I know we wrote this down once on Friday. We're going to write it down again. So write this down, permutations. Permutation is an arrangement of things in a specific order, right? When order matters, when the arrangement of things matters, right, it's called a permutation. A Rubik's Cube, the order matters, right? We don't say it's solved until all the colors are in a specific order, right? That is called a permutation. A combination is when you're just choosing some things, and it doesn't matter how you choose them, right? When the arrangement of things in no specific order occurs, that is called a combination. It's called a combination, an arrangement of things in no specific order. Okay? So, as always on all tests, you can have a resource card. So, even if you forget, which one is the combinations, which one is the permutation, you need to remember, one of them involves order and one of them does not involve order. So, the one that involves order, right, where order matters, is the permutation. One that doesn't is a combination. All right. So, recall on Friday we talked about the permutations formula, and the permutations formula looked like this: NPR, where P stood for literally the word permutation. N stood for how many things you have to choose from. You have 10 friends, and your mom says you can bring 2 of them to the movies. So you are choosing out of 10. Hey, you have a deck of cards, and the magician says pick a card. You're picking out of 52 cards. The R says how many are you choosing, right? Your mom says you can choose 2 out of 10. So you're choosing 2 out of 10. N is the 10, R is the 2. You're picking 1 card out of 52. N is the 52, R is the 1. Okay? So maybe we do some examples just to get back in the swing of things here. It says if you have 9 friends and you can only have 3 people sitting next to each other at the movies, how many ways can this be done? Right? When order matters, right? If you pick a seat, that's a specific order. Not just pick 3 friends, but pick the seats at the movie theater. That's a specific order. Right? We're going to use the permutations formula. The permutation formula is NPR, where N is how many can you choose from? So how many can we choose from right here? We can choose out of 9 friends. That's the N. The R is, well, how many are you allowed to choose? I'm allowed to choose 3. So that is the formula with the numbers plugged in. So that's not the answer, right? So how many ways can this be done? Now we use the counting principle. We're told that we can choose 3 people, okay? So the formula says I got to choose 3. So you're going to have a first choice, a second choice, and your third choice. Your first choice, you have 9 people to choose from. Your second choice, well, you already chose 1, so there's 1 fewer. Now you have 8 people to choose from. And lastly, your third choice, you have 7. We use the counting principle. We multiply those together. 9 times 8 times 7, right? This is the counting principle. And it's a big number, 504. Think about that, right? I don't know how many friends you guys have, but I probably got around 9. And if I want to pick 3 people out of my friends to go somewhere, I have 504 different permutations if we go to a movie and we sit down. right? Today, we're going to be doing combinations. And remember, combinations isn't picking the seats, it's picking the friends. Okay? Turns out there's fewer combinations than permutations. So once again, permutations, arrangement matters, combination doesn't matter. So this is the visualization of that. If I ask you to pick two, right? So today we're going to be doing combinations. Okay, take a deep breath. This is going to get really ugly really quickly. Don't panic. Just go with the flow, look at the formula, understand what I'm saying, and trust me when I say it won't be as bad as it first appears. Okay, so you're going to need to write this one down. This is going to be the formula. It's going to be. So yes, I'm going back to the movies again. So it says you have 4 friends. You can take 3 of them to the movies. How many different groups can you bring? Now remember, order in this case doesn't matter. We're not choosing seats where order does matter. Okay? We're just saying which 3 friends out of your 4 friends can you bring? Okay? So this is a combination. All right, so you can choose 4, or out of your 4 friends, you can only choose 3 of them. So I need to plug that information into my combination formula. Remember, N stands for how many people you have to choose from. So I can choose from 4 friends, so N is 4. How many are you allowed to choose? I can choose 3. So R is the value 3. Okay? Try to wrap your heads around that. Rewind the video if you need to hear that again. So now I know what N is 4. Now I know R is 3. Now I'm going to substitute those numbers everywhere I see an N and an R. Okay, so there we go. See what I did? So N is now 4, R is now 3. Now we do the math. So let's do the numerator first. The numerator says 4, choose 3. So out of 4, choose 3. So remember, you're going to have you're choosing 3, so you're going to have first choice, second choice, third choice. So when you make your first choice, there are 4 to choose from. When you make your second choice, now there's only 3. And when you make your third choice, now there's only 2. Do you understand where I'm getting that from? All right, the denominator. 3, choose 3. Well, once again, see where the R value is? The R value is 3. So I need to make 3 choices, and I'm starting with the number 3. So the first choice would be a 3, the second choice a 2, and the third choice will be a 1. In fact, the bottom number ends up being a factorial. It's 3 factorial. Now look at the fraction we just did. Check it out. We can cancel some things. 3 divided by 3 is 1. 2 divided by 2 is 1, so they cancel. Right? Now look what you're left with. 4 over 1, which is just plain 4. Remember when we did permutations, we got large numbers very quickly. Combinations will not be large, even relatively speaking, not large numbers. So if you have 4 friends and you can take 3 of them, there's only 4 different combinations of that choice, right? Make sense? All right, let's do another one. So we like these cards ones. You have 6 different cards. You can draw 3 of them. How many different groups of 3 can you draw? Right? So we're saying when you look at your cards that you hold in your hand after you draw 3 of them, how many different ways are there to arrange that? Okay? So let's see. I've got 6 different cards and I can draw 3. So 6 is your N and 3 is your R. So we're using the combinations formula. Anywhere I see N, I'm going to write 6. And anywhere I see an R, I'm going to write 3. We okay? So that's our setup right there. N is now 6 and R is now 3. Now let's see. I'm going to do the numerator first. 6, choose 3. 6, choose 3. I can choose 3, so I'm going to have first choice, second choice, third choice. But I'm starting with 6, right? So it'd be 6, 5, 4, right? First choice, I have 6 to choose from. Now there's only 5 cards to choose from. Then 5, and then there's only 4. See how that's done? The bottom one is just basically a factorial. It's 3, choose 3. So 3, 2, 1, right? First choice, there's 3. Second choice, 2. The last choice, there's 1. See how that works? Nothing cancels here. Now, you could do some cross reduction here. I'm going to choose to just multiply straight across. 6 times 5 is 30, times 4 is 120, 3 times 2 is 6. 120 divided by 6 is 20. So once again, if this was a permutation, we get a really large number, but since it's a combination, well, I guess 20 is large, but certainly not as large as if we had done a permutation of 6 choose 3. Starting to catch on? All right, let's do one together. Let's do one together. All right, how many combinations? Notice it says combinations, right? How many combinations of 2 cards can you get from 8 cards? So I kind of mixed the words up there, right? How many combinations of 2 can you get from 8? So how many cards are we starting with, or how many are you choosing from, right? I'm choosing from 8 cards, I'm choosing 2. So yeah, you have to be able to close read in order to do these ones. All right, so let's see. There's our combination formula. Let's see. N is going to be 8, and R is going to be 2. So anywhere I see an N, I write an 8. Anywhere I see an R, I write a 2. See what I did there? All right, numerator first. 8 choose 2. 8 choose 2. I'm only making two choices. So the first choice and second choice. First choice, I have 8 to choose from. Second choice, I have 7 to choose from. Starting to catch on? The bottom one is just a factorial. It's going to be 2 factorial. In other words, 2 choose 2. So first choice 2, second choice 1. Once again, nothing cancels out, but you could do some cross reduction here. I'm going to choose just to multiply straight across. 8 times 7 is 56. 56 divided by 2 is 28. So if you have 8 cards and you're only choosing 2 of them, there's 28 different combinations. If this had been a permutation, 8 PR or 8 P2, 8 choose 2, been pretty big number. All right. The last game, and you're going to see this often, is it's called selecting letters from a bag. Sometimes the letters spell a word, sometimes they don't. But it's basically you take a bunch of letters, you put them inside a bag, and it says choose a couple of them. So let's see what it says. It says, how many ways can 3 letters be selected from the letters and ZX, so forth and so on? So it looks like we're choosing 3 out of, I'm choosing 3 out of how many? Let's see, let's count. 1, 2, 3, 4, 5, 6, 7. So I'm choosing 3 out of those 7 letters there, ZX, C, V, B, and M. So 7 choose 3. So anywhere I see an N, I'm going to write 7. And anywhere I see an R, I'm going to write 3. Okay? We good? All right, well, let's see. Numerator first. 7 choose 3. 7 choose 3. So I'm making 3 choices. First choice, how many are there to choose from? There are 7. Second choice, then 6. Third choice, then 5. So 7, 6, 5. Notice the pattern that continues to form there. The number that I'm looking at the numerator there. The number that starts is the number that's on the left of the P. Right? How many choices are you making? That's the number that's to the right of the P, the 3. So notice there's 3 numbers there, 7, 6, 5. That corresponds with the 3 that's right of the P. Okay. Look at the first number there in the numerator, 7. Look at the first number to the left, or the only number to the left of the P. It's a 7. That's the pattern that it always follows. Okay. The denominator is a factorial. It's 3 choose 3. So it's always start with whatever. It's only going to be one number there. Remember, it's always going to be 3P3 or 5P5 or 7P7, that sort of thing. So you start with the number and you count down to 1. 3, 2, 1. Catching on? All right. Anything cancel there? No, there. I mean, you can do some cross cancelization there. The 3 and the 6. I'm gonna multiply straight across. Let's see. 7 times 6 is 42. 42 times 5 is 210. So we get 210 over 6. You wouldn't think that 6 goes into 210, but it does. Right? 6 goes into 21. 3 times, right? With 3 left over, 30, and 6 goes into 35 times. So 35. So there are 35 different combinations of 3 letters from a given 7 letters. Right? That's kind of a large number, right? 7 letters in the bag, and there's 35 different ways. So what would a permutation look like? What would the question look like? And you're not going to have that tonight for homework. It'll only be combinations. Permutation, the way the question would be read would be something like, you need to place letters on a page, right? So in other words, you got to write down a letter in the first place, the second place, the third. So as soon as you make the order matter, then this turns into a permutation problem. But if you're just choosing the letters, right, it's a combination. So if there's nothing about putting the letters down in a specific order, then you're just choosing its combination. Turns out when we get to geometry, algebra 2, and we do, if you take in high school, if you take probability and statistics, the course it will offer, it turns out that knowing the difference between combinations, permutations is one of the more challenging things. Okay, one more. Let's do one more. How many ways can 2 people be selected from 20? So, you have a class and the teacher says, I need 2 volunteers, right? How many different combinations are there from a class of 20? So let's see, I have 20 to choose from and I must choose 2. So let's see, 20 is the N, 2 is the R. 20 is the N, 2 is the R. You with me? All right, replace the N with 20, replace the R with 2. And let's see what we get. The numerator first. So 2 choices starting with 20. So it'll be 2 numbers, 20 and then 19. Right? See how that works? I'm just choosing 2 numbers. That's what the 2 means. But I'm starting with the number 20. So 20, 19. On the bottom, it's always a factorial. Right? Start with 2, count down to 1. 2, 1. Right? Okay. Nothing can, I could do that 2 and the 20. I'm going to multiply straight across. 20 times 20 is 400. 20 less than 400 is 380. So 20 times 19 is 380 over 2. Divide by 2. And we get, holy cow, 190. Think about that. In our class, around 20 people, right? There are 190 different ways that I can choose 2 of you. That's a lot of choices. If we had done this for permutations, it would be a whole lot more. All right, you feeling confident? You got this? All right, how about you do one all by yourself? Go ahead and try this one all by yourself. Pause the video, answer the question on the Google Forms, and then play the video and see how you did. How'd you do? All right, let's see. The question says Josh must pick 3 out of 5. 3 out of 5. So obviously that is 5, choose 3. So 5 is the N and 3 is the R. 5 is the N, 3 is the R. All right, so 5, choose 3. Numerator first. So we're going to make 3 choices, and I'm going to start with the number 5. So 5, 4, 3, right? And then on the bottom, it's 3 factorial, 3, 2, 1. All right, hey, let's see. The 3's cancel. If I multiply straight across, it gives me 20 over 10, or 20 over 10. 20 over 2, I'm thinking of the answer, and that is 10. Did you get it right? Okay. You may want to play this video a couple times just to catch on to this is certainly a messy formula, but hopefully you caught on to the pattern, and once you catch on to what you're doing, these are not that challenging at all. If you run into any problems, don't hesitate to send me an email. With that, I'll close the class, and I will see you guys, on Wednesday?